Welcome to our algebra review, where we're going to talk about arithmetic operations that you might have not used in a while and just need a refresher on. So we're first going to talk about adding and subtracting and numbers in general. So we all remember when we add things like 3 plus 10 plus 15, we'd add these numbers up together. You could either put together 3 and 10 to get 13 and then add 15 to it to give us 28, or you could have looked at this and put the 10 and the 15 together to get 3 plus 25 and again 28. The reason we can do this is because of the associative property of addition. And if you remember, it looks something like this: grouping the first two numbers together and then adding the third. But by the associative property, we could also group the second two numbers together, and that is perfectly and mathematically quote unquote legal. So we can use numbers to help us, numbers that we are more comfortable adding together first and then adding together a third number. We also learned how to add by stacking. So if I had something like 257 plus 688 plus 94, I could stack these. And by stacking, we put all the ones, it's supposed to be 257. And then the 688, I want the 6, we'll call this the hundredths column. So the 6, since that's in the hundredths place, should go there. In the tens place should go the 8, just as the 5, the 50 part of our 257. And then 8 ones in the ones column. And then 94, well, we don't have anything in the hundredths place, so we start that in the tens place. The 9 goes in here in the tens place and 4 in the ones place. And now I can add these numbers up together. And once again, I can group them to which ones work best for me. So I look at 7 and 8, and I know that's 15. 15 plus 4 gives me 19. So I put a 9 there and carry the 1, because the number 19, 9 is in the ones place, 1 should go in the tens place, so I add 1 up there. Now, putting these together, I have 1, 5, 8, 9. I'm going to put the 9 and the 1 together to give me 10, and I know that 8 and 5 is 13 to give me 23. So that's just like 230 because we're in that tens column. So the 3 stays with the tens, but the 2 has to go to the hundredths column. And I know 2 plus 2 is 4, 4 plus 6 is 10. So the answer to this is 1,039. And a real quick look at subtraction. So if I had 40,000 minus 29,056. To subtract these, I need to line them up just like I did with my addition. So I'd put 40,000 on the top, then the 6 in my second number would be in the ones column, the 5 in the tens column. There are no hundreds, so I put the 0 there. The 9 in the thousands column and the 2 in the 10,000s column, and I'm going to subtract these two. But because I don't have, I have 0 tens and I'm trying to subtract 6, I have to do, if you remember, what's called borrowing. So, since I have nothing to borrow here, 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 or here, I start at the 4 and I make that a 3. That would make, taking a 10,000s, that would give me 10,000s, so I'd put the 10 here. But I have to remember I have to borrow 1 for the hundredths place. So this would now become a 9, and this would become a 10. But I got to borrow one of those for the column next to it. So that becomes a 9, and that becomes a 10. And again, I borrow 1 from here, and now I can have my 10 in the ones column. So 6 minus 10 gives me 4. 5 minus 9 gives me 4. And remember what that is saying. That's saying 90 minus 50 actually in this column here. Then 900 minus 0 gives me 900. 9,000 minus 9,000 gives me 0. And 30,000 minus 20,000 gives me 10,000. Those are what the numbers actually mean as we do that. In our minds, though, we generally don't think that way. We just say 3 minus 2 or 9 minus 9 or 9 minus 0, that type of thing. But in reality, that is what we're doing. And it's nice to remember why we do the things that we do. Now, I suggest always to all of my students that you should know your times table up to the 12 times table. So you should be able to do 12 times 12 is 144, 11 times 11, 121, or 11 times 12 is 132. You should be able to rattle off those numbers. If you can't, I do suggest that you practice, either make your own cards or practice with somebody younger that's first learning their multiplication tables, and make a contest out of it. Make it fun. Otherwise, it's going to be hard to do. But how do we multiply numbers? Well, like if I had something like 8 times 6, I should know right in my mind that that's 48, just because I've memorized it. But what happens when I have larger numbers? So let's say that I'm saying 4,312 times 4. Maybe not so easy to do that in my head. So I would take 4,312 and I'd stack it again, almost like we did with addition. And I'd say 4 times 2 is 8. 4 times 1 is 4. 4 times 3 is 12. And then 4 times 4 is 16. And add 1 because I had to carry the 1. Because when I did 4 times 3, that gave me 2. It was actually, if you remember, it was actually 1,200. So I have to carry 1 to the thousands place. So when I do 4 times 4, giving me 16,000, I should add the 1 to get me 17,000. As my answer. So stacking it when we have larger numbers is a smart way to go. Now multiplying by any multiple of 10 is a breeze. If I had 43,260 and I'm multiplying that by 10, I don't even have to do the multiplication. When you're multiplying by tens, however many zeros or multiples of tens, however many zeros come after the 1, that's what you add to the number that you're multiplying it by. So this would become 432,600. I'm going to add that 0 at the end of that. And if I had that by, let's say I had this, times 1,000, that would mean I'd add 3 zeros after the 2. So it would be 432 with the 3 zeros, or 432,000. And that's the nice when we have, it's very nice when we have multiples of 10. Now we've been working with whole numbers. We've done addition, subtraction, multiplication. In my next segment, we'll be doing division with whole numbers. And we're going to talk about, there are a lot of numbers other than whole numbers that we work with, such as integers, rational numbers, and irrational numbers. But we'll talk about those later. See you in the next segment.